I am sure you are already familiar with universal square, but do we know what all these holes are for? Let's take a detailed look at what they are used for, and other functions of this cool square. The universal square comes with this cardboard that gives us some indications of how to use it, but the surprise comes when we turn it around, and we discover that the universal square has other functions that we might not have expected. This square is not only prepared to mark the necessary holes for installing cup hinges, it also serves to mark where to make the holes for these pieces that hold the shelves of bookcases, or these similar ones that have a screw with an eccentric to press the edge of the shelf against the face of the board where it is joined. And also, it is prepared to make the mark for installing these large eccentric connectors. I bought these with these large decorative covers, and I think they have a very 70s look. Come on, let's go with the universal square. If we place the heel against the board, thanks to the holes we can draw parallels as if we were using a marking gauge. From here they rise every centimeter starting at 0, and from here they also go every centimeter, but starting at 30 and going backward. For example, this is how I draw a parallel 5 centimeters from the edge of the board, and this is how I draw a parallel at 8.5 millimeters. By dragging the pencil point, it centers against the curvature of the hole. We can see that each hole also coincides with the ½ centimeter of the opposite scale. That's why with this hole, I could draw a parallel at 8.5 centimeters. I don't know exactly what this 45-degree angle is for, but if on a strip or a wooden beam, I draw 2 perpendiculars. And now, adjusting this edge against the perpendiculars, I draw these lines. I join the points, and I have a line that goes exactly through the center. Now here is a small notch. And here I have slots at 45 and 30 degrees. They continue here to be able to draw long lines more precisely. Okay. If I mark against this edge, I think the origin is given by this vertical. And if I mark against this edge, I think the reference is the inside of the notch. It's a matter of testing with the pencil we have. So I draw this vertical and let's see how it goes. I draw against this part of the slots. And there I have the line, perfectly at 30 degrees. The heel comes off very easily. You just have to loosen the screws. No need to remove them. And we can put it this way. Or this way. In both cases it fits well here on the edge of the square. Here we have the drawing of a compass. There we see it. We can put a nail here, and it serves as a pivot point to draw circles. If I want to draw an angled line from here, the center of this hole must align with the edge of the board, and with the angle mark that interests me on this scale. The angle it marks is this with the vertical. For example, I align the 35-degree mark and the center of the hole with the edge of the board, and I put the edge of the square next to the point from which I want to draw the line at 35 degrees. There I have it. To the other side would be the same, as the universal square is painted exactly the same on both sides. If we prefer, we can place the hole next to the mark and align it with the edge of the board and the degree mark. For example, the 30-degree mark. In this case, I would mark against the inner edge of the square. There I have the 30 degrees. In case you didn't notice earlier, I changed the position of the heel to have the angle facing forward. That angle is 45 degrees. I think it's a very short section to support and place the square at 45 degrees precisely. But if this hole here, this one, I align it with the edge of the board so that the bottom part is tangent. Like this. I can draw it 45 degrees more precisely. This is probably just a coincidence, but it seems to work well. The next thing I like a lot. I draw two verticals. I draw two parallels. And there I drew a perfect rectangle in a couple of seconds. Notice now that here it says this arc has a radius of 40 millimeters from the hole, and the outer radius says it's 60 millimeters. So this width is exactly 40 millimeters. And this one is 60 millimeters. I'm going to draw a 40 millimeter arc in the corner of the board. I could do it by eye, but if I draw this line, and now this one, I have the center of the arc. Now, if I place the lines next to the edges of the square, the arc I draw will be too far inside, so I put the center in the center of the hole. And notice how now the edges of the board peek through here. This way, I can draw a perfectly tangent arc with the edges of the board. If I draw these lines, I have the center for the 60 millimeter arc. But this time, as I draw outside, I have to leave the lines like this outside the edges of the square. There I have the arc perfectly tangent to the edges of the board. If I put the center inside the hole, notice how the edges of the arc go off the board. And conversely, with the small arc I draw inside, if I move the center out of the hole, notice how the arc would be too far inside. The scales of the square start right at the edges of the metal, one to each side. This allows us to use the side that interests us most in each case for measuring. For example, to precisely mark where to drill holes to place supports for the shelves of a piece of furniture. Let's see what all these holes are for. Let's suppose this is the door of a piece of furniture. We'll start by testing how well it marks for 35 millimeter and 26 millimeter cup hinges. First, I make a mark to center the hinge on each side. And I draw the verticals through the marks. This is the furniture. This is the door. Are 37 millimeters from the heel. These two holes, 32 millimeters apart. They are for marking where the 35 millimeter hinge plate goes inside the furniture. These other two, which are 28 millimeters from the heel, are for the 26 millimeter hinge. In both cases, the distance between holes is the same. As I said, they are for the plate that goes inside the furniture. Now here we have a hole that is 21.5 millimeters from the heel. This marks where the 35 millimeter hinge cup goes. And here I have the one for the 26 millimeter hinge, which is 17 millimeters from the heel. We'll look at this hole and this other one later. Let's start with the 35 millimeter one. I slide the heel of the square until the hole for the cup is over the line. And I draw a little circle over the line. That's where I would drill with the 35mm cup bit. I would insert the cup, and with the hinge itself mark the holes for the screws. Now for the 2 holes inside the furniture, I miss having a notch or a mark here that gives me the center between holes. I need it to easily place the 2 holes at the same distance from the vertical. The first hole is exactly 50mm from the edge of the square. The center between each pair of holes is 50 plus 16. It is 66mm from the edge. And the 66mm coincide slightly to the right of the 65 degrees on this scale. That's where I'll have to align the perpendicular I drew before. Okay, I need to extend the vertical. I adjust the 65-degree line slightly to the left of the perpendicular. And I draw a little circle in each hole. I would just have to drill the holes for the screws. I'll leave a link to another video where I install cup hinges, step by step. Now let's go with the 26mm one. I align with the 65 degrees. I mark with the holes below. And before I use this hole. Now I mark for the 26mm cup with the hole that is 17mm from the heel. And there I would drill holes for the screws of the plate. Here I would drill with the 26mm Forstner bit, and then I would drill the holes for the screws of the cup. Pay attention to this. The heel measures 18mm in height, and it measures 16mm in width. If I place the large eccentric connector with the side facing outward from the board against the metal of the square, notice how the end of its slot is centered with the edge of the heel. We'll see how to install them later. Now, the heel is 16mm and the board is 16mm. I put the pencil there, and this way I mark the center of the edge of the board. Easy, easy. 8mm and 8mm. Now let's go with the hole to install these 2 pieces with a diameter of 20mm. It's this one which is 9.5mm from the heel. There is a difference between the 2 pieces. It's the position where the metal dowel goes on the side of the board they face. Let's go with this one. I make the mark. And this line is to align later with the other board. Okay, normally we would first mark the vertical line where we want to place it. Well, when I drill there with the 20mm Forstner bit, drilling so close to the edge should leave a notch. And I won't need to drill a hole for the metal dowel. The same goes for the other piece. When I make the hole, it will leave the notch for the metal dowel. To measure where to drill the hole for the thread of the metal dowel on the side of the other board, I think the same measurement should work. And this notch, aligned with this 15mm hole, will serve as a reference. I'm not entirely sure. We'll see in a future video. I'll remove the heel, make the mark, and see how everything aligns. The 25mm diameter eccentric connector has a longer dowel. We will use this 33.5mm hole to mark. This way I easily mark where I will have to make the hole with the 25mm Forstner bit. This time, I do have to mark where to drill on the edge, the hole for the metal dowel, because the eccentric connector hole will be far from the edge. But at what height from the edge do I drill the hole? Well, with the edge of the heel, I could mark the position where I need to make the hole for the metal dowel. But I think everything will be easier if I make the holes centered on the edge. The difference is, at most, maybe a millimeter. Or I could align the wooden dowels I put for reinforcement with this same mark. It's about making it easier to mark where to make the holes and to drill them for the dowels, both wooden and metal, on the edge of this board, and on the face of the other board. And in a future video, I will use the square to test how to place these pieces so that the boards are exactly where we want them. Thanks for watching the video. And if you like my videos, subscribe to my channel and hit the bell.